Bismillahirrahmanirrahim. This is another video about forced RL circuit or driven RL circuit, as Mr. Hayt says. And here we'll be solving practice problem 8.9, which is related to example 8.7. Now, in case of a RL circuit or driven RL circuit or forced RL circuit, we generally use this formula. Now, where F could be either voltage or current, depending on the circuit. For RL circuit, it is current, and for RC circuit, it is voltage. Since ours is a RL circuit, therefore, we'll use the current equation. From here, we'll write IT, then I infinity, IT 0 plus, minus I infinity e raised to the power minus t over tau. Now, to find the net equation, we have to find the value of I infinity, we have to find the value of I 0, and we have to also find the value of this function tau. Tau is the time constant. Now, the question here has broken it down into 4 parts. It says the voltage source 60 minus 40 ut is in series with the 10 ohm resistor and 50 ohm inductor. So the circuit will be something like this: a 10 ohm resistor and a 50 millihenry inductor, and this is the source. Now we have to find these 4 parameters. We'll do them one at a time and compare with the given answer. So let's come to the first of all, the source. How do you define this source? 60 means it is 60 positive, negative, both sides for infinite period. So we just draw a line for 60. Then minus 40 ut means that after 0 towards right, we have a negative 40 and it goes up to infinity. So this is the representation of this circuit. Now this could further, this value can be further simplified and can be written as that before 0 the value is 60 and after 0 it is 60 minus 40, that is plus 20. So this is what is applying on this network. Okay, now for t less than 0, the concept here is that we are operating here. This is 0 line. We're just short of 0. That means the voltage is 60 volt applied voltage. And since this voltage is for long, the circuit is in steady state condition. And in a steady state condition, we replace the inductor by a short circuit. Just for your knowledge, this is from another video, and this is for capacitor charging, but just I want to give you the concept of t less than 0. So this is 0 point t less than 0, it is steady state. From t greater than 0 to some point in t, which is up to 5 tau, the circuit remains in transient state, and then it becomes steady state. So the steady state condition is called the t infinity state. Okay, so back to this. This is the circuit. Now we can find current. We'll call it I0 minus, which will be the voltage divided by the resistance of 6 ampere. Now the question says we have to find current and voltage and the magnitude of it. So this is the magnitude. Now voltage, this voltage, now we'll call it VL0 minus. And we'll write the KVL equation from here. So going this way, minus 60, I into 10, so I into 10, and this is VL0 plus VL0 minus, sorry. And from here, putting in the value of I, which is 6, we get the answer of VL0 minus to be 0. This is 0. You could have found this directly from here just by seeing the circuit. Since there is no resistance, therefore there will be no voltage drop across this, and the voltage drop would be 0. Okay, and this is the answer. First part of the answer is the same that we found, 6 ampere and 0 volt. Part 2 is to find the same thing at t greater than 0. Now again we are back to this diagram, and t greater than 0 means we are just slightly ahead of 0. Two things will happen here. The first, the current through the inductor does not change. So whatever is the current here, the same will be the current here. That means I0 plus will be equal to I0 minus, and which we have found to be 6 ampere. So this is one condition. What about the voltage? As I mentioned, the moment we cross 0, the transient state starts. And in the transient state, the inductor will not be a short circuit. It will remain there. But what we'll do is we'll just write this voltage across the inductor as VL0 plus, and we'll write the KVL equation. So going from here, minus 20 current into resistance plus VL0. And from here, we can calculate VL0. This is 6 into 10. So it will be minus 40. And now especially the magnitude is important. So we'll take magnitude of this, which will be plus 40. And that is the answer given. Third part is to find the current and voltage at t is infinity. That means it has, we are here in the steady state condition. So same condition, now inductor behaves like a short circuit. And by V over R, we find the current. This divided by 10 is 2 amperes. And by KVL, we'll find the voltage, same technique that we followed earlier. IL is 2 here. So plugging in the values, VL infinity is also equal to 0. Same logic, since there is no resistance, it should be 0. So these are the three parts. The most important part is this one. Generally, this is given in the most of the question, that find the current and voltage at time t is equal to 1 millisecond or 5 millisecond or 10 milliseconds. Now for this, we have to write the general equation. And this we discussed earlier. And for RL, we have the current equation. This is the equation. We know a couple of values. We know I infinity, we know this value. We don't know tau. So we can find tau from here. These two we already know. But tau is L over R. L is given and R is given from using this formula. The tau is 0.005 second. So now we'll plug in all the values. So this is 2, this was 6 minus 2, e raised to the power minus t, and divided by 0.05. Further simplifying, we get this equation. Now this is our general equation, and we can find the value of t at any time by using this equation. Since we have to find here for 3 milliseconds, so for t we'll now use 3 milliseconds. So I 3 millisecond, 4 e raised to the power 3 millisecond and divided by 0.05. Solving. The current is 4.2 ampere. And now voltage, same technique, KVL rule that we have applied. So minus 20 current into this and the voltage VL. So VL from here can be calculated to be 22 volt. So this is the answer. I hope you have been able to follow this. Please let me know through your comments. Thank you.